For a closed surface S and a point function f vector, prove that these two integrals vanish identically. So here we are going to use the Gauss Divergence Theorem. So first one is, we need to show that this given surface integral vanishes. So for that we are going to use the Gauss Divergence Theorem. For Gauss Divergence Theorem, we must have this n vector with ds, right? For that, let's use one result. The dot product of n vector with curl of f vector is equal to curl of f vector and its dot product with n vector. These two are equal. So I'm using this result first. So this is equal to the surface integral of, writing here curl of f vector, its dot product with n vector, and then ds. So now I'm having this n vector with ds, and now we can use the Gauss Divergence Theorem. So this surface integral is equal to the volume integral of divergence of this vector, curl of f vector dv. To show that this integral vanishes, for that we need to just show that the divergence of curl of f vector is equal to 0, right? So remaining to prove that the divergence of curl of f vector is equal to 0. For that, let's take this f vector to be equal to f1i vector plus f2j vector plus f3k vector. And now taking the curl of f vector, that is del cross f vector. So this is equal to, just write here I vector, j vector, k vector. And in the second row write partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. And now writing the components of f vector. So this is f1, f2 and f3. So let's get this curl of f vector. So this is I vector, partial derivative of f3 with respect to y, minus partial derivative of f2 with respect to z, minus j vector. Partial derivative of f3 with respect to x minus partial derivative of f1 with respect to z, plus k vector, partial derivative of f2 with respect to x minus partial derivative of f1 with respect to y. Please mark this as 1. And now to find the divergence of curl of f vector, right? So how to find this? Partial derivative with respect to x of the first component of curl of f vector. What is the first component? This one. Plus partial derivative with respect to y of the second component of this one. Because I'm having negative sign outside, let's take this negative sign inside. So this is partial derivative of f1 with respect to z minus partial derivative of f3 with respect to x, plus partial derivative with respect to z of the third component, this one. So this is partial derivative of f3 with respect to x and y, minus partial derivative of f2 with respect to x and z, plus partial derivative of f1 with respect to y and z, minus partial derivative of f3 with respect to y and x, plus partial derivative of f2 with respect to z and x, minus partial derivative of f1 with respect to z and y. So these two cancelled out, and these two cancelled out, and these two cancelled out. So we are getting this divergence of curl of f vector to be 0. So this is 0. Marking this as 2. And let's substitute this 2 in, let me mark this as star. So substituting 2 in this star. So substituting this divergence of curl of f to be 0 over here. So we are getting the volume integral of 0 dv. So that is equal to 0. So we have got this surface integral to be 0. That means this surface integral vanishes. Now the second part, to show that this surface integral is 0. So here we are going to again use the Gauss Divergence Theorem. By another format of Gauss Divergence Theorem, where cross product is used, this surface integral is equal to the volume integral of curl of del V dV. So this is equal to the volume integral of curl of grad V. Grad is gradient of V. Marking this as 1. Now to show that this surface integral vanishes, for that we just need to prove that this integrand is equal to 0. Now this curl of grad V can be written as del cross del V, right? Okay, so this is equal to, writing here I vector, j vector, k vector, partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. And what is grad of V? It is partial derivative of V with respect to x, I vector, plus partial derivative of V with respect to y, j vector, plus partial derivative of V with respect to z, k vector. This is your grad V. So now writing the components of this grad V over here. So partial derivative of V with respect to x, partial derivative of V with respect to y, partial derivative of V with respect to z. And now solving this. So this is I vector, partial derivative of V with respect to y and z, minus partial derivative of V with respect to z and y, minus j vector, partial derivative of V with respect to x and z, minus partial derivative of V with respect to z and x, plus k vector, partial derivative of V with respect to x and z, minus partial derivative of V with respect to x and y, right? Now this term and this term are equal, so these two cancelled out each other. Again these two cancelled out with each other, and these two cancelled out with each other. So we are getting this to be equal to 0. So we have shown that curl of grad V is equal to 0. Please mark this as 2 and substituting this 2 in 1. So this is equal to the volume integral of this is 0 using 2. So this is equal to 0. So we have shown that this given surface integral vanishes, right? So by the use of Gauss's divergence theorem, we have shown that these two surface integral vanishes identically. Alright, thank you.